Good afternoon, grade 8. Welcome to this lesson. Grade, I think I opened the wrong slide. I'm sorry. I'm confused today. Okay. Let me quickly. This is where we are. Welcome to this lesson of electrical systems and control. Okay. I'm sorry about that confusion. I can't take you back to grade 8. You passed that grade. Right. We are doing Ohm's law, resistors and circuits, resistor codes, calculation of resistance. And we'll be looking at the relationship between resistance, voltage, and current. First of all, do you remember that yesterday we did circuits? We did connection of circuits in series, parallel connections, and you looked at those components that you connect in parallel and in series. And we noticed that the more lights we connect in a parallel circuit, the dimmer the light, because the output components share in the current. They share the current and they split it up. So we saw that, and we did logic gates. Okay, we did the AND or and the AND and OR function. We did truth tables. Now, that was just electrical circuits. Today, we introduced this fellow here. Okay, this is called a resistor. Now, that is what makes us grade 9 different from the other grades, because now this is the beginning of our electronics. Okay, right. What is a resistor? What is it to resist? A resistor is a specially designed component that is normally used in a circuit to limit the current. You know, when you are resisting, you inhibiting a response. Okay, maybe if you say, hi Auntie Lindy, and I'm resisting your greeting, maybe I will say hi in a very low voice and say hi. You say, hi Auntie Lindy, and I'm like, hi. So I'm just somehow being reluctant to greet, and maybe I am resisting to greet you. I'm resisting you, you know. This is the fellow that is doing the resistance in a circuit. When the current wants to pass, this fellow here doesn't really allow much of the current to pass through. It's like when the current is knocking, saying, can I please come in? This fellow here will open the door slightly. He will not welcome the current to pass through. You see, this is a conductor. This part is still a conductor. There's current, it wants to pass through. But when it comes here, this fellow will resist the passage of the current. So we call this one in electrical systems and control a resistor, because this one likes to resist flow of current. Resistors are made of materials with a high resistance to electricity flow and come in the form of thin wires or films. okay? Because this is also a conductor, but it is, you see this extension, it is also a conductor, but it is a conductor that doesn't really open the door wide for the current to flow, okay? Resistors have precise resistance values that don't change much in different environmental conditions, okay? And the most used resistors look like tubes with 2 wires to connect it to the circuit. And the wires are metal, okay? You know that metals conduct electricity very well. The symbol to show a resistor in a circuit diagram is an open rectangle or a zigzag line, okay? I once heard an engineer saying, South Africa belongs to an international body of engineering of electronics and electricity. Okay, so they have their own conventions, international conventions. So in our schools, we allow both the rectangle and the zigzag line. But if you can Google any circuit diagrams from the internet, you will find the zigzag line because that is more internationally recognized as a symbol than the rectangle one. But in our circuits in grade 9, we take both the symbols as correct symbols. These are the symbols, okay? So this one is the one that you are familiar with in your textbooks. Other textbooks, they come with this one. And I've just told you that this one is the one that is more internationally accepted, okay, by this body that regulates the engineering of electronics and electricity, okay? So that's why you will find this one on Google, on some textbooks, but even this one is correct. So what is resistance in a circuit? I did talk about resistance yesterday, okay? We said an output component, it offers some resistance. Even the battery itself, a battery can be attached to a certain value. For instance, the 9-volt battery, it comes as 1 unit, but the amount of voltage in that battery will be affected by the resistance of the battery itself. It offers some resistance itself. And then when you connect a circuit, the output components in a circuit, they also offer some resistance, all right? So apart from the resistors, apart from these components that I've just shown you here, which are called resistors, these are really designed for the purpose of resistance, of inhibiting the flow of current in a circuit. Apart from them, output components are also offering some resistance, like the light or the buzzer or any other output component in a circuit. It does offer resistance in that circuit. Electricity flows far more easily through copper wire than through plastic wire, string, or grass. So that is why you find our electric wires being copper, because copper is a good conductor. You want to speak to me? Hello, Unkabetsi. Right. Copper wire has low resistance to electricity flow, whereas plastic wire has a high resistance. Okay. So because copper wire has low resistance, it is a good conductor. Because electricity flows easily through copper wire, copper is a good conductor of electricity. To resist something means to try to prevent it. I told you, if you sit in a tree and the wind blows hard, you can resist falling down by clinging to the branches. Yeah, if you understand resistance. To conduct means to allow something to pass through. So to conduct is the opposite of resistance. Resistance is inhibiting the passage of current, but to conduct is to allow the passage of current. The resistance that an object, for example, a wire, offers to the flow of electricity can be measured. We can measure resistance. Resistance is measured in ohms. We use the symbol, that omega symbol. That is the symbol that we use for the units of resistance. Remember yesterday I showed you this omega sign on the multimeter. Okay. Right. When electricity flows through a conductor, heat is generated. Some metals such as nickel and chrome resist the flow of electricity quite strongly and heat up when electricity is forced to flow through it. The heating elements of stoves and kettles are normally made of a mixture of nickel and chrome. I can ask you a question. Why do we choose to use nickel and chrome for heating elements? It's because these materials, nickel and chrome, these metals, they resist the flow of electricity and they heat up when electricity is forced to flow through them. And that accumulation of heat is what heats up your water. When some metals get extremely hot, they emit light. When something emits light, it is a source of light. A light bulb is a source of light, but a mirror is not a source of light, as it only reflects light. Okay? The difference between emitting light and reflecting light. That's the difference. The light bulb emits light and the mirror reflects light. Right. Okay. How to determine the value of resistors? I want you to be very careful now because this is what you are going to work on a lot. How to determine the value of resistors. Low value resistors often have their resistance value printed on them in numbers, while high value resistors are coded using colored bands. The first three bands give the value of the resistor in ohms. The color code chart will help you to work out the resistance value in ohms. The fourth band of a resistor shows the accuracy rating as a percentage. This is also called the tolerance. The band is gold or silver, depending on the tolerance. For the circuits you will be building, this is not important. Now, I'll tell you what the tolerance is. Remember, a resistor resists the flow of current. So the resistance is measured, but it does allow some current to flow. It inhibits some and allows some. So a resistor will have a certain amount of resistance and a certain amount of tolerance. Okay, so the tolerance is how much the resistor is allowing the current to flow. The resistance is how much the resistor is blocking. Okay, because I said the resistor will open the door slightly for the current. The resistor will say, okay, just try to squeeze in only in this space. I'm not going to open wide for you. So that is tolerance. But the amount of the amount of closing the door because the door is not wide open. Now, kilo means multiply by 1,000. Kilo means multiply by 1,000. For example, 1 kilometer, okay, is 1 meter times 1,000. That's a kilo. Kilo means multiply by 1,000. Mega means multiply by 1,000,000. Units of measurement is ohms, kilo ohms, and mega ohms. So kilo ohms will be ohms multiplied by 1,000. Mega ohms will be ohms multiplied by 1,000,000. Right? There is the illustration there below. What is to short circuit? I know you have encountered this word a lot. Surely you have heard somebody saying there is a fault here. This appliance has short circuited or something like that. Have you ever heard that? We must guard against short circuit when you are connecting circuits. What is to short circuit? If the resistance in a circuit is very low, for example, when the terminals of a cell are connected with a piece of thick copper wire, the current flow will flow very strongly. This is called a short circuit. If from the battery, there isn't much resistance and the current is just flowing openly, it's like flooding the circuit, that is called a short circuit. It can result in so much heat being generated that damage is caused to the cell and the other parts of the circuit. The conducting wires can melt and the fire can start. So short circuiting can be very dangerous. Let me show you let me tell you about an example of short circuiting. If I were to connect a circuit, but then my conductor, my electric wire, it goes back to the battery without any output component, what will happen? The battery will heat up. The battery will heat up and that will damage the battery because it's a short circuit. Normally, in a normal circuit, the input would be the battery and then the output would be another component. Maybe there could be even a switch in between, as you saw yesterday in those circuits that we did. By adding more resistance to a circuit, you can control how great the current is that flows through the circuit. Maybe you can add other components like the lamp, the buzzer, and other components, resistors. Okay, you can put resistors. By adding more resistance, then you are controlling the flow of current. We need to protect the components from short circuiting. How do we do that? We use resistors so that current will not flow freely. We don't open the door wide in the circuit for current to flow. Okay, we open just a little bit so that the current doesn't burn or damage the other components in the circuit. In this way, you can protect the components in a circuit from too much current flowing through them. Increasing the resistance also means the cell or battery powering in the, powering the circuit will last longer, because you don't want this current to flow from the battery and back into the battery. It's going to damage it. So you protect other components, you protect the battery by introducing resistors. You can add precise amounts of resistance by using resistors with the required resistance value. Remember, voltage has values. Remember yesterday we used the multimeter. We looked at the multimeter and we said we can use the multimeter to check the values of voltage, current, and resistance. So you can check how much voltage there is in a circuit, and you look at the value of the components. Some components cannot take an amount, a certain amount of current. Have you ever seen at home when you plug in something, an appliance, maybe the adapter will start burning? Have you ever noticed that? Who has ever seen that? Sometimes you plug in even an extension, and then the extension starts burning. Why? Because the current that comes from the plug is too big for that appliance that you have plugged in, and it burns. Yes, Unkabetsu, you've never seen that. Actually, this is what happened in my home. There was a power outage. When there was load shedding, when the power came back, it was too big for the appliances and our TV was damaged. Okay? And we had to buy a certain specialized adapter to protect the appliances in the house. So that is what too much current can do. So you need to control. Actually, the resistors are control components in a circuit. They control the flow of current so that current doesn't damage components, so that current doesn't damage the appliances. If you can check your appliances at home, like, I'm not saying go and break your parents' things, but if you can find an old radio or just old appliances, you will find resistors inside, and those resistors are soldered on. They are soldered on. Yeah, no, see, Paul, because I wasn't at home, I didn't switch off my plugs. So the load shedding started and it ended while I was at work. When I came back, the TV was not working. And my children told me that, no, this is actually what happened. There was load shedding. When the lights came back, the TV was not working. But also on my part, I should have bought that that adapter that you use to protect your appliances. I now have it. It costs about 300 and it's called the surge plug. The surge plug. I bought the surge plug. Yes. Yeah, the surge plug. Yes, I bought it. Yeah, it's the first surge, the first surge. So the surge plug is like a resistor. Also, it does the duty of a resistor. It doesn't allow that big current to flow into your appliances. So I think now you understand resistance. Ne? Do you understand resistance? Yeah, yeah, Unkabetsi. Yeah. No, Sipho, hey. You know, when you are irresponsible, like I was irresponsible for not buying the surge plug, you learn a very bad lesson because I had to buy another TV. Okay, I had to buy a new TV just out of the blue very quickly also because you cannot stay without a TV in your house. So you need to control current that goes into your appliances. So resistors, even inside the appliances, you find resistors. They resist the flow of current because current can be bad. Now, I wanted to study this. Okay. I wanted to study this. This is how you work out resistance using color codes. Now, this is a way to determine the value of resistance. The first band, there is let's start from the right. The first band is the one that we said is for the tolerance on the right, okay? That one doesn't count for resistance. But when we are calculating resistance, we start on the left, okay? We start on the left, all right? And we are using this one, which is 4,700 ohms. Okay. So you look at these digits. You look at these digits and the color codes. That is what you can use to determine the value of your resistors. When you look at the band that is on the right, it seems separated. It is far away from these three. Okay? So that's why you can easily see that it doesn't count for resistance, but it counts for tolerance because it is farther away. Besides this, you can use the multimeter. You use the multimeter. The multimeter will show you the actual resistance of this resistor because the resistor can have these color codes which show you the value of that resistor. But maybe in class you have used that resistor many times. Okay? You have used that resistor many times. Now, when you have used this resistor many times, it has lost its value that is written by, that is shown by the color codes. When you are using your multimeter, although the resistor is like this, it shows that it's a 4,700 ohm resistor. But the multimeter will give you the accurate reading at that time you are using your resistor. So it's very important that you understand that the display on the resistor of the colors cannot be relied on as the actual value of that resistor. That is why always in the classroom you must have a multimeter, because even your cells, your power source, you will measure their actual value with your multimeter. But apart from the multimeter, you must learn how to interpret this. So let's see how you interpret it. We have different resistors here. This one has 3 lines, okay? And this one has 4 lines, has 5 lines, okay? 4 lines for resistance, and this one is for tolerance. Let us look at what these lines are. Okay. You have your first digit, which you will identify by the color. So the green, you know it's a 5. The yellow, you know it's a 4. So you will record it as it is. Then the second digit, you look at it, the colors, the colors are attached to some values. Yeah, let me say that. So this one here is brown. What is the value for brown? It is 1. So you know that this is 1. And the third digit also, you have your black. Your black is a 0. Okay? And then this last one, because this is a resistor with 5 bands. This last one, this color, is it a maroon? You know that the maroon, now this one is a multiplier. This one is a multiplier. So you will know that the multiplier will give you how many zeros? Okay? It will tell you how many zeros must be there. So, because it's a maroon, we know that there are 2 zeros. So there are the 2 zeros. So this is just the number of zeros. It is the multiplier. It gives you the number of zeros. Okay? When you can look at this one, this has 3 zeros. This color has 3 zeros. So because it's a multiplier, you know that, okay, for this band, I will add 3 zeros. See? And then you get the value. Let us look at the top resistor. The first color is this yellow. So we look for the yellow there. It's a 4. We record the 4. The second color is that purple. And the purple, we look at it here. It's a 7. Okay? And it's a 7. So we record the 7. Then the third line is a multiplier. The last line, it's a multiplier. Then we go to this color. How many zeros are there? 3. So we record the 3 zeros. That gives us the value. So it's 47000. We record it here. It reads as 4,700 ohms. That is the value of this resistor. But when we are connecting circuits, we still have to use the multimeter because we don't know how long this resistor was staying in the shelves in the shop. We don't know. Maybe it has lost some resistance because of some factors. We are going to attach the multimeter here and measure resistance like I showed you yesterday. Did you see the multimeter attached to a resistor? We use that. That is going to give us the accurate resistance because sometimes you find that it has a resistance that is slightly bigger than this or slightly less than this if it has been used in other circuits before, or maybe if it has outgrown its shelf life. But by looking at these color codes, you can determine the value of the resistor. Okay. Tell me, did you understand? I know you will not remember all these colors, but at least you can have this chart. You can have this chart handy in class when you are working with resistors. But let me ask you, did you understand how we use this chart to determine the value of the resistor? Happy, I'm happy, Kwezi. So every time we are connecting electronic circuits, we want to work with resistors, we bring this chart. We bring this chart and we have it handy, put it on the table, and then we check the resistors. Then we can quickly determine the value of our resistors. And you see that they are not the same. Some have 3 lines for resistance, others have 4 lines for resistance, and the farthest line that is not closer to the others, it is for tolerance. So this one has 1% tolerance. Okay, so it's 51,000 ohms. 51,000 ohms plus 1%. Hey, that's high resistance and little tolerance. And this one is 4,700 ohms plus 5% tolerance. Okay, so if it is a 3-lined resistor, the last one, the third one, should be a multiplier. If it is a 4-lined resistor, it's 5-lined, okay, including the tolerance one, you have the last one as your multiplier. So at all times, the last one is your multiplier. So you will write these digits as they are, but this one is a multiplier. It is the number of your zeros. Okay, it's the number of your zeros. Okay. Grade 9. Now, work out the resistance of each of these resistors. So you have your purple, your black, and your brown. Let's go and check. So this is a digit multiplier. And this is your tolerance. Let's see. It's a purple, black, brown. Let's check purple, 7, black, 0, brown. Brown is 10. Okay? Brown is 10. So what will be your value for this resistor? What will be the value for this resistor? It's 700 ohms. It is 700 ohms. It's 700 ohms. 700. 700 ohms. With a tolerance of 5. Okay, let's look at the 5. This is a 5. Yes, 5% tolerance. Very good. This one is a brown, purple, green. This, the answer is 1,700 ohms, but let's go and see how we got that. 1,700, it's a brown, purple, green. A brown, there, 1, purple, 7, green, 5, a multiplier. Our multiplier is green. So we have 5. So it's 1,700 ohms. This one, kilo ohm. What is a kilo ohm? 7.5 kilo ohm. Kilo is multiplied by 1,000. Okay? So this one is 7,500, 7.5 kilo ohm. Okay. $7,500, yes, 7.5 kilo ohm. Sometimes when you get a 1,000 ohm resistor, it will be written in your textbook as a 1 kilo ohm. Okay. This is a 43 mega ohm resistor. Okay. Mega ohm, what is mega ohm? We said mega ohm is multiplied by 1,000,000. Okay, that's a mega ohm. Okay, now Ohm's law. Why do we study Ohm's law? What is Ohm's law? There is a special relationship between the voltage, current, and resistance in any circuit. You can control any one of these 3 variables by changing the other 2 variables. For instance, if you change voltage, current and resistance will be affected. If you introduce resistance, then the 2 will be affected. So you can control. You see, resistance is controlling current, the flow of current, you see. And current comes from the power source, which gives us voltage. So resistance is controlling, like restricting the flow of current. So you see, that is the relationship between voltage, current, and resistance. You can control any one of these by changing the other 2 variables. Then what is Ohm's law? Ohm's law states that as voltage increases, the current increases if the resistance is constant. Okay? If voltage is low, current will be low. Okay? Depending on resistance. Because if resistance perhaps is high, it doesn't matter if voltage and current are high. Resistance will restrict its flow. So you see, these 2, current and voltage, they are affected by resistance. So current will increase with voltage depending on resistance. Ohm's law states that as voltage increases, the current increases if the resistance is constant. A variable is a quality that can have different values. For example, an amount of water in a tank. Okay, that's a variable. Okay, we can have any amount of, we can have an amount, an X amount of a voltage, because power sources, they differ in value. Then we can have, depending on voltage, we can have an amount, an X amount of current. Okay, so these three are variables. Resistance, you just saw now that resistance can have different values too. A constant is a quality that always has the same value. For example, gravitational acceleration. It always has the same value. Sometimes we call a quantity a constant because we decide to keep it constant. So, like resistant, we can keep resistance constant if we want. Okay, so Ohm's law states that voltage, as voltage increases, current increases too, if resistance is constant. That is Ohm's law. Ohm's law speaks to the relationship between these three. Okay, we have to end our lesson there. Next time, we'll look at the formula for Ohm's law, because we need to determine the values of these three variables in our circuits. Let me love you and leave you. Grade 9. I hope that you benefited a lot from today's lesson. Hope to see you tomorrow. Have a great evening. Bye.